Hey everybody, this is Alex Merced, developer advocate at Dremio. And as promised, what I did is I posted on LinkedIn this Ask Me Anything post, where I basically said you can ask me anything. So what I'm going to do now is just kind of go through the comments on this post and answer questions as best I can, and mainly to kind of spur a conversation about these topics: Dremio, Nessie, Iceberg, the kind of things that, get me excited and awake in the morning. So let's go here. So first we have when using a REST catalog or Nessie catalog. So this is particularly dealing with Apache Iceberg and different catalogs to track your metadata in Apache Iceberg. Is there a way to also connect to Athena to get the benefit of using Glue catalog? Okay, so this has to do with sort of one of the current sort of aspects of Iceberg that can oftentimes lead to some difficult decisions. So let's just talk about how this kind of works. But bottom line is this. There are multiple Iceberg catalogs. Generally, at the moment, they are sort of mutually independent. So if you use one catalog, you can't use another catalog. Now, as far as I understand, Athena is based on Trino, and Trino does support REST catalog, Nessie catalog, and Glue catalog. So you can probably connect all three catalogs to Athena and query them with Athena. But then there's the additional thing is that each catalog kind of has its own unique benefits that you may want from that catalog. Can you actually get the benefits of all three? Okay, so let's just talk about sort of like how catalogs work. Okay, so bottom line is you have an engine. Okay, so here we have like a compute engine. This could be Athena, Trino, Presto, Dremio, one of these engines that want to query your Iceberg tables. Essentially what it's going to do is that it needs to know, if you say, hey, I want to query table A, it needs to know where the metadata for table A is. Okay, so essentially like, over here is your storage, and your storage, it contains your metadata and data. Okay, so essentially what's going to happen is that there's going to be a separate mechanism known as the catalog. Okay, and essentially what's going to happen is that every time you query an Iceberg table, the engine is going to sit there and say, hey, I'm looking to query table A. Okay, where can I find table A? Okay, and then basically the catalog is going to say, well, table A's current metadata is located used based on this file over here in this file. It's actually, now that I think about it, very similar to how DNS works. So if you're not familiar with what DNS is, that's domain name service. So if I type in like xyz.com, there's this intermediate server, a DNS server that says, oh, okay, well, xyz.com is really this IP address. Okay, so it provides sort of that catalog of domain to IP in the same way that a Iceberg catalogs basically give you a mapping of table namespace to metadata file. Okay, but there's different tools you can use as your catalog, because all is really required is some sort of mechanism that actually stores that namespace, that mapping of a namespace to a metadata file location. Okay, so there's a lot of different interfaces. Okay, so essentially we have some of the older ones are like JDBC. So you could use like JDBC database as a catalog. Actually, I'll just kind of copy and paste that. Yeah, JDBC. You have Hadoop catalog, which is, I'm not a big fan of the name of that catalog because it makes people think that you have to use Hadoop. It's really the file system catalog. It's really sort of the I don't have a catalog. So you're not using an actual formal catalog. So essentially you're just writing files to your file system, and then you're going to create this little file called like version hint.txt that actually points to the newest metadata file. So when you're using that catalog, the engine doesn't sort of make a request to a catalog. It looks for this particular file, which will enumerate, hey, this is the newest metadata file. Okay. Then there is DynamoDB catalog. So you're basically you're storing that reference as a DynamoDB reference. There is Glue catalog. Okay, that's going to allow you to use a Glue metastore as a catalog. There's Hive catalog. That allows you to use like a Hive metastore as your store of. Then there is Nessie. Okay, Nessie allows you to use Nessie, which is an open source catalog implementation. Okay, so again, the difference between a sort of an implementation and a specification. This is specification is sort of like a how, while a implementation is a what. Okay, so Nessie is an implementation of a catalog that's meant for like really using for Iceberg, and brings what's, one way to look at it is what's called, you can call it like catalog versioning. Actually lately I've been liking the term multi-table versioning, because I think that captures more what it's doing, in the sense of allowing you to, since it's capturing snapshots of your entire catalog, it allows you to do things like multi-table transactions, multi-table rollbacks, multi-table time travel, multi-table tagging, lots of really neat stuff that's only really possible when you're using Nessie. Cool. So that's Nessie, and then there's Rest catalog. Okay, and this is where things branch off a little bit. Okay, so we have Rest catalog, and Rest catalog isn't necessarily an implementation. Okay, Rest catalog is a spec. Okay, so basically it's a standard REST API spec for that any catalog implementation can use, so that way they can just use the same connector. So essentially what you're seeing now is many catalogs using this REST catalog spec as sort of like the standard. So right now, what we've seen so far, to my knowledge, is things that are using the REST catalog spec include Tabular. Okay. Tabular. Unity catalog from Delta Lake. So that's kind of how they're facilitating that whole like Delta Lake 3.0. So basically, if you're using Unity catalog in Delta Lake and you're syncing your Delta tables to an Iceberg metadata using that uniformat feature, what it's essentially doing is it's exposing sort of an Iceberg catalog from Unity catalog using the REST catalog spec. And then 3, I want to say Snowflake is probably going to use the REST catalog once they kind of, right now it's in like, their stuff's in private preview, so I don't know exactly how it's implemented, but my guess is that they're going to take advantage of the REST spec. So, because the benefit of, if you're a new catalog and you take advantage of the REST spec, it saves you the trouble of having to build connectors. Now you don't have to build a connector to anything that already supports the REST catalog. So you build a new catalog specification, right, or new catalog implementation, and you basically use it using the REST catalog spec, then the result is that you suddenly now have like Trino, Presto, Snowflake externally managed tables, Star Rocks, Apache Iceberg support. So that's kind of like the benefit of it. It's like a basically you bring the catalog, and then the connectors are available now everywhere. Okay, because each catalog connector requires a separate implementation for each engine. Okay, so not every engine supports every catalog. I would assume over time that probably everything will kind of, you'll start seeing like a REST catalog for implementation for JDBC, for Toho, for Dynamo, for Glue, for Hive, for Nessie. That would be my guess in the long run. Again, there probably will be like benefits to using sort of like the native connectors versus sort of a REST catalog implementation, depending on the type of tool. But I imagine you're going to start seeing some coalescing around that. Okay, so the point of all that was just to understand that like each catalog connector is sort of unique, and each catalog has different features. So for example, if you're using Glue catalog has all sorts of interop with all of other AWS's tools. So it's really easy to bring up your Iceberg tables in Redshift, in Athena, and other aspects of the AWS ecosystem because it's connected to your Glue catalog. With Nessie, you get all that multi-table versioning benefits. With REST catalog, you get the benefits of whatever catalog you're using, whichever catalog implementation you're using. So you might be using like some of the automated data management from Tabular, or really you're working with Delta Lake and you're translating it to Iceberg using Databricks, or maybe your Iceberg tables are part of your Snowflake environment, and they're basically living on Snowflake, but you just want to maybe do X, Y, Z from Spark or Dremio or something like that. So essentially, like that's a catalog story. So at the moment, there is no way to sort of have multiple catalogs. It's not impossible theoretically. Okay, really the way you would do that now is you would probably have to create a custom REST catalog implementation. And if anyone's looking for like an idea for a simple startup, this would probably not be a bad idea to create like a service that basically is a catalog of catalogs, and essentially like you would use that catalog, but it actually will keep multiple catalogs in sync. So essentially you would read and write to that catalog, and then every time you write, it'll sync your Glue catalog, it'll sync your Nessie catalog, it'll sync your catalog for whatever other platforms you're using to give you that sort of uniform reach across tooling, and also the ability to use benefits of different platforms that makes it exclusive to different catalogs. So if anyone's wants to do that, go for it. My plate is full, so it won't be me. But that would be what you would need to do. You would have to create a catalog that basically, when data is written to it, would then sync to the desired catalogs. I know Tabular has a feature similar to this. So if you're using Tabular Catalog, they do have a feature that'll sync to Glue Catalog. So that is sort of the closest thing to that I'm aware of at the moment, as far as like being able to kind of cross sync catalogs. But then the Glue catalog is read only in that situation. So you'd be able to read from Glue catalog, but you wouldn't want to write, because then you get into consistency issues, because I think it's only like a one-way sync. It'll periodically take whatever the updated reference is on Tabular and sync it to the Glue instance. Again, I think there's a market, or even for an open source project, that is a catalog that allows you to sort of connect multiple catalogs and keep them in sync in some sort of sensical way. I think that's something to that extent will be an inevitability, because there are sort of unique benefits to some of these, particularly like Nessie, Glue, REST kind of have their benefits, especially depending on sort of which implementation you're using. Okay, but right now, basically, it's the story right now is you kind of have to choose a catalog, and like that is how you move around your Iceberg tables from tool to tool, and then you're limited to sort of the features of that catalog. And now, I forgot one catalog. Now that I think about it, this is probably like the newest one, which is the LakeFS catalog. So this one's fairly unique as well, because LakeFS provides versioning as well, but more specifically at the file level, and they do that through like dynamic pathing. So they had to kind of change the core Iceberg spec to include, like, there's a proposal for relative file pathing that has not yet been accepted into the Iceberg spec. So LakeFS has sort of preemptively adopted that into their catalog because it's necessary for the functioning of their system. So essentially, if you wanted to use like LakeFS with Iceberg, you would have to use their catalog. And then again, that would, just like choosing any of these catalogs, would preclude you from using any of the other catalogs on this list. So it's like you choose a catalog, and that's your Iceberg entry point. And that story's been improving quite a bit. Again, I think over time, chances are a lot of things will sort of coalesce with at least adapters for REST catalogs. So you might still have, like, let's say a LakeFS catalog, but then with like a REST catalog adapter, or a Nessie catalog with a REST catalog adapter, or a Hive catalog with a REST catalog adapter. So that way you can get the benefits of a native connector, but also get the reach of the REST catalogs, the REST catalog connectors. But yeah, so bottom line is, if you really wanted to do that, you'd have to build a custom REST catalog implementation in today's world. Okay, next question. Can you please list out features of 1.40? Okay, let's do that. Okay, so let's head over to the Iceberg repo. So that'd be github.com/Apache/Iceberg. And let's go to release notes. Okay, right here. Release 1.40. Okay, so I'm not gonna go through each one, but we'll talk about some of the more interesting. Well, they're all interesting if you know what they're doing, but sort of the things that are gonna more affect sort of your immediate workflows if you're working with Iceberg. So implement bound expression sanitization, remove overflow checks the default counter, causing performance issues, support anything that improves performance issues is always going to be great. Okay, so that's the thing. Every time these formats get updated, there's oftentimes performance improvements. So the problem is, it makes it hard to kind of really trust any benchmarks, because benchmarks are always backward looking. They're always like versions ago. And I think like the latest Iceberg and Delta Lake benchmarks are quite a few versions ago. At least ones that are like public. I mean, I know of some that are sort of in transit, but not complete yet. And as far as I'm aware, like for the most part, all these formats have, if you're using what a data engineer would, the kind of like sorting patterns, partitioning patterns that an engine engineer would, use, you're not going to see horrendously different performance, and like who's better kind of changes as each version comes out, because they're all sort of chasing that tail. So they're all going to be really performant. So John, oftentimes when people ask me like, oh, but what about performance? I just wouldn't choose which format you use based on performance, because that's always going to improve. It's really going to come down to tooling what tooling do you use? So for example, I mean, if you are very, very vested in the Databricks ecosystem, you're probably going to lean towards Delta Lake, and you might want to use Uniformat to get exposure to some tools that are only Iceberg. If you are using a lot of tools that are not Databricks, if you really have like no Databricks footprint at all, then it probably makes more sense to use Iceberg, because more non-Databricks tools have more wider support for Iceberg. Um, you know, if you're really just looking to stream data, and then Hoodie might make sense there, because Hoodie's really strong, has a really strong streaming story. It just depends on sort of what you're trying to do, okay? What tools you're using. And again, the tools matter because certain formats don't have support with certain tools, so you want to make sure that you don't choose a form that precludes you from tools you plan on using. And same thing goes for Iceberg catalog selection. So those are all questions you kind of want to like think about as you kind of go over all these things. But again, performance is constantly improving for all formats. And again, at the end of the day, also performance is heavily dependent on the engine, because the engine actually has to implement all these like query optimizations. So it's not just Spark. Everybody always says benchmark Spark, but there's all sorts of tools out there that, depending on the engine, like if I'm using Photon, regardless of all the optimizations that Iceberg may have, Photon's probably going to perform better on Delta because it's built for that. Okay. And it's not open source, so it's not like someone can then go improve how it does planning for like Iceberg. Okay, vice versa, other engines may be better on Iceberg because a lot of the engineering has been more able to do more so on the Iceberg side, because the spec kind of changes slower, so it's easier to kind of keep up. Cool. So again, these are just all sorts of thoughts. Okay, support incremental scanning with branch. Okay, anytime you see incremental anything, that's very good, because it just means performance, because you're not doing full scans every time. Validation API, the delete files, which validates files exist. Okay, so that's just basically making sure that, hey, like if it says there's a delete file there, that it's actually there, preventing sort of errors from being thrown. This is a decently big change. So basically, when you create a table, it's going to use the V2 spec by default. Okay, now the way Iceberg typically works is that every time you go to a new version, like if you go to the bi-weekly Iceberg meetings, and that's the great thing about Iceberg, that they have these public meetings. Everyone can be involved in the discussion of how the project evolves. Okay, you won't get any surprise new features. You'll know ahead of time. They're beginning discussions of like what V3 will include, and that work that's going to include all sorts of really interesting new features. So eventually V3 will be a thing, and then you'll be able to, so now V2 will be the default when you create a new table, and you have to opt into V1 and then in the future V3. Okay, and then again, the point of that is just sort of like what features are unlocked. So certain features of V2 aren't available to V1 tables, and certain features of V3 won't be available to V2 or V1 tables. Okay, so it just depends on sort of like where you want to be in the spec. Okay, you use CSTD compression for Parquet by default. Okay, so that's just changing a default. Okay, based on sort of like probably what's the most sensible default. Again, different compression algorithms are going to have different trade-offs between sort of speed and performance on those files. All the exact sort of like, I have an article on this about the different compression algorithms. So if you look at my LinkedIn blogs, you'll find it, that kind of go into sort of like which ones, will get you more compression but less performance, and which ones will, maybe balance out those trade-offs. So I'm assuming that's going to give you sort of like the best balance. Okay, add strict metadata cleanup mode and enable it by default. Okay, so again, that's just, quality of life. So these are all just improvements. Just seeing if there's anything really, inputs is useless. File and position bounds for deletes. Okay, yeah. Here's a big one. Okay, so basically so a big thing. So you heard me mention earlier that like Nessie is the only one that does multi-table versioning, and that's still the case because of the unique way that Nessie works. So Nessie, the way it works is that it's every time any table changes, there's not just the table level snapshot, but Nessie tracks its own catalog level snapshots. So it will be a listing of all the different namespaces and the metadata and a small bit of metadata related to each namespace. So essentially the metadata location. So in that case, you can create a separate sort of chain of catalog level snapshots separate from your table level snapshots. which enables all those multi-table features. Okay, so what they're trying to do with this is expand the REST spec so that way, if a catalog wants to, so again, just because this has been added doesn't mean catalogs can, but it adds the right endpoints to the REST spec so that way, if they want to enable sort of a more of like a begin transaction, end transaction type workflow. So this is different because you're not capturing catalog level snapshots. So it's the different mechanism. What you're doing is you're saying, okay, we're going to say start here, so and then do these transactions, and then once all these transactions are done, commit them at the end. Okay, so you've ever seen like sort of like that begin transaction, end transaction syntax. That's essentially what it does. It's going to execute and stage those changes, but not commit them till every transaction's been successfully completed and staged. Okay, so that's sort of the idea here. From my understanding in the last Iceberg meeting, at the moment, it's mainly for staging multiple fast forwards. So essentially, if you're using branching at the table level in Iceberg, so when you create, so basically that does create an alternative chain of table level snapshots. What you would do is you would sort of like grab those commits from the branch and you can pull them over to the main table. So that would be referred to as a fast forward because you're essentially fast forwarding it to this particular commit. If you want to do that, you can now do that across multiple tables atomically. So essentially, the workflow would be is you'd create, like, let's say I want to do transactions on table A and table B. I would create a branch on table A, create a branch on table B, do my work on those two tables and on their respective branches, and then I could use these new endpoints if the catalog allows for it to do a fast forward on multiple tables. Okay, so essentially, this changes the spec, and then yeah, so I think this is just basically adds the ability for. So I don't know if there's an implementation of it. I assume like Tabular probably will have the first implementation of this, but the spec is there. But again, that's different than the way Nessie works. So again, in this approach, basically, again, you would still branch at the individual tables, and then you would just use these endpoints to sort of atomically do the fast forward. Versus like on Nessie, what's happening is you're creating a branch of the catalog level snapshots. So you're creating one branch at the catalog level, and then you would do all your transactions across those catalog snapshots. And then, so you're never really messing with the tables still only have a singular history per se from the way the metadata is written. The only difference is like there's multiple metadata files that establish multiple histories. But then what would happen is that you would then merge that catalog snapshot to the main branch. So instead of having to like, so essentially all you're doing is you're moving over one commit over. You end up kind of in the same place, but again, the form allows there for it to be like multi-table tagging, multi-table rollbacks. It allows for a couple other types of things you can do that this, at least at the moment, precludes you from. But again, there's a difference, but the idea here being a way that's more table centric because the Iceberg spec is meant to be sort of more table level centric. So that way, like, two tables aren't necessarily interfering with each other per se. So, and there's pros and cons to every approach. It just depends on sort of like what use cases are going to work for you more often. Okay. Default to exponential retry strategy in REST client. Export registering tables with REST client. Okay, so there's a register table method in Iceberg. So what this method does is just basically allows you to point it to a metadata file for an existing table so you can add it to an existing catalog. This allows you to move the table between catalogs but maintain the history. Okay, so I'm assuming we're just adding REST catalog support to do that. Okay, add last updated timestamp, add total. So other updates. And then again, another big thing was adding support for Spark 35 and the drop support for Spark 3.1. So basically, if you're using Iceberg with Spark 3.1 and you want any updates to Iceberg, you will have to create a fork of Iceberg and then cherry pick the changes to get that 3.1 support. Deprecate support, so they're no longer going to update the support, but it'll still be there for now. And then right now, so basically the supported versions are 3.4, 3.5. If you're using Spark, you'll want to basically get updated. Increase default. This is just other like updates there. So pushing down system functions. Okay, these are just Spark performance updates and other fun stuff. Link, same idea. Basically, just other quality of life benefits in different areas. But yeah, basically the REST, beginning of sort of multi-table, the beginning of allowing for multi-table transactions natively in Iceberg is probably the biggest thing here, and the changes in Spark support, and then the changes in the defaults, like default V2. But a lot of this is going to improve performance, and provide quality of life benefits. So again, all of these formats are just going to keep getting better. So it's like, if the issue is ease of use, if the issue is performance, those stories will improve for all the formats. The things that I think are more indeterminative are things more like how the table's long-term evolution, and sort of multi-tool support, which I tend to weigh those more heavily when making such a decision. Cool. So let's see here. Let's go back to our questions. Okay. Jeremy, using Hive and Iceberg, any benchmarking report? Okay, I talked about benchmarking a little earlier, but I talked about the 1.4 features. Okay, so two things there. As far as unique features to Iceberg, probably the two most unique features, well, I'll say three most unique features of Iceberg is one, partition evolution. So the idea is that you can evolve your partitioning scheme. So essentially the reason why this can work is because it has to do with the way each format kind of keeps track of the metadata. So essentially, like, the metadata for the co-location of sort of like partitioning data and file statistics are actually more decoupled in Iceberg. Okay, so where the actual partitioning scheme and schema is in the metadata.json in Iceberg, while the stats for any individual file are in the manifest files in Iceberg. So they're completely separate places. So in that case, I can use the same data files, but I can always be applying sort of a different partitioning scheme or partitioning schema because I just read that separate file altogether. Okay, and like, let's say Delta Lake, my understanding is that's going to be in those log files. So every time you're sort of adding files, the partitioning stats are sort of coupled with the metadata for the new file that's added. Okay, so there's basically, if you can't change the partitioning, because you'd have to go back and rewrite those old files that track the adding of that file, whatnot. And again, the spec may change, so like nothing is ever etched in stone for any of these formats, but basically, because Apache Iceberg, just the way its metadata is structured, enables this. So essentially what can happen is that, let's say a few commits in, like I've been ingesting data with a yearly partitioning because of the amount of data we've been ingesting, but now the amount of data we're ingesting is growing, so it makes more sense to now partition it by month. I can partition it by month going forward without having to rewrite the previous data. I can if I want. So if I do a rewrite data files procedure, it will go back and rewrite the files based on the current partitioning scheme, but it's not something I have to do up front, and it's something I can do incrementally, because when I do a rewrite data files procedure, I can specify, hey, rewrite this year, not every previous year, or something like that. You can provide filters so that way it's not rewriting all data all the time. So you have some flexibility there. The other big feature is hidden partitioning. This is essentially a quality of life feature for the data engineer and the data analyst. For the data engineer, it makes it just really easier to apply certain types of partitioning. So if like I'm doing month partitioning, I can just say, hey, I would just use a partition transform and just say, hey, partition based on this timestamp field by month, and I'm done. Well, in the past, and like let's say Hive, I'd have to kind of create like a derived column and then make sure that I generate data for that derived column. So there'd be a month column on top of the timestamp column. And then and then the data analyst would have the problem of having to like add that additional predicate where they have to query in the month column, because even if they query the right timestamp, they say, hey, give me all data between these two timestamps, they'd still scan the full table unless they said, okay, only give me the data between this month and that month, because that was the partition field. With hidden partitioning, I just filter on the timestamp column, and this metadata tracks it. The partitioning is based on the transformed value of the timestamp column. Okay, so the way the partitioning is tracked is different, which enables that sort of easier partitioning, easier to execute, like easier for me to define, and also easier for me to use, because now I'm not having to have two filters. One filter is enough. So I can just do what intuitively would come to me as a data analyst, and I'm still going to get the benefit of that partitioning. So that's a really nice, because in the past you'd have people who forget to add the additional predicate and do full table scans that would take hours and hours, if not days, depending on the data set. So that's a really big sort of quality of life piece. Okay. Yeah. So let's continue on. And then I said 3 unique features. The other big unique feature with Iceberg is sort of like the separate. It's also it's basically there's trade-offs, but it's the decoupling sort of like of the folder structure. And so essentially what happens is that Iceberg really operates off these manifests, which are lists of files with their metadata, but also their absolute file path. Okay, so basically, and because there's an absolute file path, those files can be located anywhere. They don't have to, all the same files with the same partition don't have to be in the same folder. They can be anywhere, which has several different implications for how you would migrate, for how you deal with certain bottlenecks. And the benefit of that, it does offer you some new ways to deal with certain bottlenecks, and it offers you easier path to migration, because you don't have to move the files into like another folder per se. You can use what's called the add files procedure. Just say, okay, here, add this file to the list, which is, I think, coming up in the next question. Yeah, and that's nice. That's very nice. I mean, the trade-off is you have to have absolute path, so it's not like you can have you don't have relative file paths. So if I were to just literally copy a folder with an Iceberg table, just copy the folder and email it to somebody, it would break the table, because all those references in the metadata are now broken. Because it's not based on how the files relate to each other in the file system, it's based on what's hard-coded in the metadata. Although, again, the use case here is supposed to be for big tables, and you're not zipping up over and emailing. It's meant for sort of really large tables that are kind of sitting in one place, and you're giving access through the catalog. The catalog becomes a mechanism for hey, if I want to give you access to this table, I'm going to give you access to be able to connect to this catalog. And that catalog will allow your engine, whether it's Dremio, Trino, Presto, to send that query over and query that data, assuming you have the right credentials for that storage. Okay. So, yeah. And then as far as being able to write an Iceberg table without an engine, no, because that's kind of what engines do. Even if you're using DuckDB to query Iceberg tables, that's still an engine. There are basically the Iceberg, the PyIceberg library and the Iceberg tools are not meant for running actual queries per se. They're meant for working with the metadata. So with PyIceberg libraries, what you can do is you can create a new table, which would create the metadata for a new table. It doesn't write any data files. You can create new snapshots to an Iceberg table, but you have to write the file. So essentially what would happen is that you would have some separate process that writes the Parquet files. So you could write your own code that writes the Parquet files, and then you would pass those Parquet files to a function that would write the manifest files, and then you would pass the list of manifest files to a function that writes the manifest list, and then you would pass that manifest list to a function that writes the metadata.json, and then you would update the catalog. So you can do that with the PyIceberg library. Let me qualify that. You're going to be able to do that with the PyIceberg library. You can definitely do that with the Java API, but for the Python, Rust, and Go APIs, that's to come. Okay, Rust and Go for Iceberg for Go, Iceberg for Rust are very new, so that's really in the early stages. But eventually, you'll be able to do all operations on the metadata. Okay, the idea of the Iceberg libraries isn't for you to write the actual Parquet data sets. That's going to be, the idea is that your engine or your process would write the actual data, but then Iceberg's job is to provide the metadata on those files that allows engines going forward to query it efficiently. And then Iceberg, the Iceberg libraries, and I think you can do this with PyIceberg, is you can generate sort of a query plan or a list of files based on sort of different expressions. So you can sit there and say, hey, get me all the files with data that matches this expression, and it'll return you a list of the data files from that Iceberg library that that have the relevant data. So essentially the query plan. And then you would pass that list of files to, like, let's say something like DuckDB, and then DuckDB could scan that list of Parquet files. Like, that's how it worked. I think now DuckDB is about to have some deeper Iceberg integrations to make that even easier. But yeah, that's essentially, like, generally, like, the thing, anything that would do that full thing end to end. Basically take your request, generate the data files, update all the Iceberg metadata, and do the whole thing end to end. That would technically be an engine. So you cannot really do this without an engine. There's certain pieces of this you could hand do the whole step with the tools that are out there, but you're probably not going to do that as an optimal way as an engine where you have teams of developers constantly trying to find ways to optimally execute certain SQL statements or data frame functions that are built to be to optimally do things under the hood, etc. Can you show an example of using add files? And now this would probably be this should probably be a full blog post and something I have to play around with this just to see if to replicate the problem. But basically they're saying, can you show an example of using add files API? So add files is a procedure in Iceberg that allows you to sit there and say, hey, this file, add it to my Iceberg table. And then we'll basically create a new snapshot and then a new manifest that includes that data file or data files. I had some issues when using truncate. So the idea here is basically the table is partitioned based on one of those transforms. Okay, so basically it's not just a partition of, hey, partition based on X column. It's based on the truncated value of column X. And the files had the mix of values could span multiple partitions. Okay, so the problem here is that the file doesn't exclusively have, so basically, let's say, for example, let's say we're doing this based on first names. Okay, so basically there's a partition for people with the first name of letter of A, B, C. So we're saying that here we're trying to add a Parquet file that has people with first name letters A, B, and C. More than likely, I don't know this for a fact, but I think the data has to match the schema and partitioning scheme of the table you're adding it to. So you would probably have to take that file and chop it up into separate Parquet files ahead of time, because basically that table is going to say, hey, this data is supposed to be partitioned this way, and you have data you basically the partition range, the partition value range here doesn't comply with like the partitioning scheme. So you would have to go back and like separate out those partition values and make sure that each of them are in their own individual data file, if that table is going to be partitioned that way. Because if not, you kind of break the spec, because the idea is that there shouldn't be data for multiple partitions in the same data file for an Iceberg table. So chances are, if you're having issues with that, it's probably because of that. You're adding files that maybe don't match the schema or don't match the partitioning schema of the table you're adding it to. Like, you can add arbitrary tables, but it should be formatted to match the structure, the structure of the table that you're adding it to. Okay, or at least to the extent that the table can at least knows how to coerce those particular. Let's say it's a different schema slightly, that it knows how to coerce the data. It has the data that it's going to need to apply the current schema, current partitioning. You might run into problems. Even if it does successfully add the files, like you might run into situations where like that file gets accidentally pruned because it kind of falls. They're not gonna. I can't imagine it's gonna have 3 entries in a manifest list to cover multiple partitions that file is in. So if it did add the file successfully, it probably would only add 1 entry that only associates it with 1 partition. And then if you're scanning, a different partition, that file gets pruned even though it has data from that partition. Like, and that basically the bottom line is, if you want to do add files, you want to make sure that the files match the table you're adding it to. Like, it's really useful if you're creating a new table that matches pretty much with your like, let's say you're migrating from, a purely Parquet table data set to a Iceberg data set, and when you initially move the files, that table matches the exact schema of what the Parquet data set was. Then after the fact, you may want to do maybe like partition, like a alter table statement to update the partitioning going forward. So that way later on when you do like a rewrite data files, or you do some compaction, it can then rewrite those data files appropriately at that time with the new partitioning scheme. So that would be my thoughts on that. So hopefully you guys enjoyed this. I think this video is like way too long to post directly on LinkedIn, so I am going to have to post this on uh, YouTube and share here. So my name is Alex Merced, developer advocate at Dremio. Hopefully you guys enjoyed this. And again, if you guys enjoyed seeing me answer and ask questions, I will be in January at Data Day, Texas, doing a Apache Iceberg Ask Me Anything. So if you want to ask more questions, and again, if you also want to ask questions on Dremio, on Nessie, on just the data lakehouse architecture in general, like when should I use it, when shouldn't I use it, what are my use cases, or I have a particular use case, and you know, this is my problem, what should I do? Feel free to send me those questions. I love talking about these things. I'll see y'all later. Have a great day and enjoy.